హలో ఎవ్రీవన్. పబ్లిక్ ఎగ్జామినేషన్లో క్వశ్చన్ నెంబర్ 3 మ్యాట్రిసెస్ టాపిక్ నుంచి ఒక 2 మార్క్స్ క్వశ్చన్ కవర్ అవుతుంది. బేసిక్గా డెఫినిషన్స్ అడగడానికి స్కోప్ ఉంది ఈ క్వశ్చన్లో. ఆర్ అదర్వైజ్ సింపుల్ క్యాలిక్యులేషన్స్, అడిషన్, సబ్ట్రాక్షన్, మల్టిప్లికేషన్ ఆర్ స్కేలార్ మల్టిప్లికేషన్ ఆఫ్ మ్యాట్రిక్స్, లేదంటే ట్రాన్స్పోజ్ కాన్సెప్ట్ పైన ఇలా చాలా చిన్న చిన్న క్వశ్చన్స్ వస్తాయి. సో ఈజీగా మనం 2 మార్క్స్ స్కోర్ చేయొచ్చు. అయితే ట్విస్ట్ క్వశ్చన్స్ అంటే డెఫినిషన్స్ కదా, జనరల్గా ఒక 2 మార్క్స్ క్వశ్చన్ ట్విస్ట్ క్వశ్చన్ ఇస్తే డెఫినిషన్స్ ఇవ్వాలి. అయితే డెఫినిషన్ ఇవ్వడానికి స్కోప్ ఉన్న ఇంకొక టాపిక్ ఏంటి అంటే ఇక్కడ మ్యాట్రిసెస్ కూడా. ఎస్, సీ ద క్వశ్చన్ హియర్. డిఫైన్ a triangular matrix. This is the question. You know that triangular matrix is a square matrix and either above the principal diagonal or below the principal diagonal. If all the entries are zeros, then the matrix is called triangular matrix. That is, two types of matrices are here. One is upper triangular matrix and the other lower triangular matrix. In upper triangular matrix, below the principal diagonal, all the entries are zeros. And lower triangular matrix, it means above the principal diagonal, all the entries are zeros. And remember that triangular matrix is a square matrix. Suppose if the question is asked, define a triangular matrix, then you have to write what is triangular matrix. Also you have to explain two types. See here what I am writing. Triangular matrix is a square matrix such that the condition such that either above or below the principal diagonal the entries are zeros. This is the definition of triangular matrix, and it is divided into upper triangular matrix as well as lower triangular matrix. Let us define upper triangular matrix first. And then we go for lower triangular matrix. Upper triangular means above the principal diagonal the entries are zeros. That is, you can define that if capital A is a matrix such that if the entries are of the form A of ij of n cross n, triangular matrix is a square matrix so that both rows and columns are same and the entries are usually denoted by A of ij. If A equal to Aij of n cross n, such that the entry Aij is 0 for all I greater than j. A21 ఉందనుకోండి, 2 greater than 1 అంటే A21 కంపల్సరీ 0 అవుతాయి అనమాట. అంటే అప్పర్ ట్రయాంగులర్ మ్యాట్రిక్స్లో ప్రిన్సిపల్ డయాగోనల్ కంటే కింద ఉండే వాల్యూస్ జీరోస్ అవుతాయి. In this case, A is called upper triangular matrix. That's all. An example. Suppose A is a matrix of order 3 cross 3. Suppose principal diagonal entries are A, B, C. Below the principal diagonal, all the entries are zeros and the remaining are present, may or may not present. But below the principal diagonal, it is must, the values, the entries in the matrix must be 0. This is about upper triangular matrix. Next, second one, lower triangular matrix. Lower triangular matrix in which above the principal diagonal the entries are zeros. That is, you can write the definition. If capital A is a matrix of order n cross n with entries denoted by A of ij, such that Aij is 0 for all I less than j, then A is called lower triangular matrix. Example. Suppose a 3 cross 3 matrix if I choose, principal diagonal entries A, B, C, and suppose below the principal diagonal the entries are P, Q, R. It is must above the principal diagonal the entries are zeros. So this is lower triangular matrix and this is upper triangular matrix. Yes. This is about triangular matrix. Maybe the question asks define upper triangular matrix, define lower triangular matrix, or simply define triangular matrix. It is enough to write this data. Next, move to the next one. Define transpose of a matrix. Transpose means just you have to interchange rows and columns. That is, rows into columns, columns into rows. Here, A is a matrix of any order. Suppose A equal to A of ij of order m cross n. Then transpose of A, that is obtained by interchanging rows and columns. That's all. It is denoted by A transpose is denoted by A prime or A transpose T. When the definition is asked, you have to write the definition as well as example also. If suppose A is a matrix whose entries are 1, 2, 3, 4, 5, 6, that implies its transpose written as 1, 4 here, 2, 5 here, and then 3, 6. This is transpose of a matrix. Next question, construct 3 cross 2 matrix whose elements are defined by A of ij equal to half of modulus I minus 3j is there. Here you need to construct a matrix of order 3 cross 2, that is 3 rows and 2 columns matrix. So that let A of 3 cross 2, A of 3 cross 2 that indicates 3 rows and 2 columns. A11 A12, A21, A22, A31, A32. This is the matrix of order 3 cross 2. 3 rows and 2 columns. And here already given in the question, A of ij equal to half of modulus I minus 3j. So that independently find the values of A11, A12, A21, A22, A31, A32 and then substitute them in the matrix A. Yes, since A of ij, that is given as 1 by 2 I minus 3j, so that A11 first, next A21, after that A31, and then I am going to find A12, next A22, after that A32. A11 A11 written as half of 1 minus 3 into 1. This is half of, next 2 1, I value 2, j value 1, half into, next I value 3, j value 1. This is half of 1 2, I value 1, j value 2, 2 2, I value 2, j value 2. Next I32, I value 3, j value, here it is 2. Now simplify this, we get the values. This is 1 minus 3 become minus 2. Modulus minus 2 value 2 divided by 2 gives the result 1. Inside the modulus you have 1 minus 3. Mod minus 2, that is nothing but 2 divided by 2 gives the value 1. And this one is 2 minus 3, that is modulus minus 1 here become 1. 1 multiplied by 1 by 2 gives half. Next 3 minus 3, that is 0 here. Next you have to write 3 times of 2, this is 1 minus 6, that is minus 5. Modulus minus 5 value 5, so we get 5 by 2. Next this is 2 minus 6, 2 minus 6 value minus 4. Mod minus 4 is 4, 4 by 2, that become 2. Next 3 minus 6, 3 minus 6 value minus 3. So that what we get here, applying modulus 3 and multiple 1 by 2, so that we get 3 by 2. And after calculating all the elements, then you have to write required matrix. Required matrix A of 3 cross 2, that is first A11 1, A21 1 by 2, A31 that is 0, next 5 by 2, 2 and 3 by 2. This is your answer. Yes, here first row first column element, this is first row second column, second row first column, second row second column. This is third row first column, third row second column element. 1 1, yes 1 1, next 2 1, 3 1, after that 1 2, 2 2, 3 2, substitution in place of ij. On simplification it is minus 2, that is 2 by 2 1, minus 1 by 2, that is modulus you have 1 by 2, 0 by 2, next it is 5 by 2, this one 4 by 2, that is 2, next 3 by 2. So substituting all the values we get required matrix. See this question, find x, y, z and a where given that two matrices are equal. This is the question based on equality of two matrices. Equal matrices, equality of two matrices is defined by their corresponding entries. If suppose equal, then these two are equal matrices. So that since here matrix x minus 3, 2y minus 8, z plus 2, 6, if it is equal to 5, 2, minus 2, a minus 4, since these two are equal, their corresponding entries are also equal. Therefore, I am going to write here by equality of two matrices. By equality of two matrices, corresponding entries should be equal. So, x minus 3 equal to 5, first one. Next here 2y minus 8 equal to 2, and then z plus 2 equal to minus 2, and after that 6 equal to a minus 4. If you simplify all these, we get x, y, z and a. From this you can write x value 5 plus 3, that is x value become 8. Next 2 times of y equal to 2 plus 8, 2y equal to 10, and the value of y equal to 5. Next z equal to minus 2 minus 2, therefore z equal to minus 4. Next a equal to 6 plus 4 implies the value of a equal to 10. Very simple. Just you have to equate the corresponding elements. Then automatically on simplification we get the value of x, y, z and a. See this one. There are two matrices, capital A and capital B. Here the question is find 3 times of B minus 2 times of A. Scalar multiplication with a matrix. Here first you have to write given data. Since A equal to matrix with entries 1, 2, 3, 3, 2, 1 and B is given by 3, 2, 1, 1, 2, 3. Now we need to find 3 times of B minus 2 times of A. This is first matrix, this is second matrix. 3 times of second matrix B, that is 3 times of 3, 2, 1, 1, 2, 3 minus 2 times of matrix A, entries 1, 2, 3, 3, 2, 1. This is equal to 3 into 3, 9, 3 into 2, 6, 3 into 1, 3. Next 3 into 1, 3, 3 into 2, 6, 3 into 3, 9. Here outside constant is multiple for each and every entry in the matrix. Next 2 into 1, 2, 2 into 2, 4, 2 into 3, 6, here 6, 4, 2. On subtraction, corresponding entries you have to subtract. 9 minus 2, 7, 6 minus 4, 2, 3 minus 6, minus 3. Next 3 minus 6, minus 3, 6 minus 4, 2, 9 minus 2, 7. So this is the matrix 3B minus 2A. Another question. There are two vectors capital A and capital B, and given that 2 times x plus a, that is equal to b, then the question is find the matrix capital X. Here given that capital A is a matrix with entries 1, 2, 3, 4. Next, capital B is given as 2 cross 2 matrix, entries 3, 8, 7, 2, and also given the third condition 2 times of x plus a, that is given by B. Result 1, this is 2 and this is 3. Yes, 3 can be modified in this way. 2 times of x equal to b minus a I can write, and from this capital X written as half of difference of the matrices b and a, half of b minus a. Yes, so that to get capital X you have to write outside 1 by 2, and here you have to simplify b minus a. B matrix with entries 3, 8, 7, 2, next minus of A having entries 1, 2, 3, 4. Yes, therefore capital X written as 1 by 2 into, here difference of two matrices is obtained by writing difference of corresponding entries. 3 minus 1, 2, 8 minus 2, 6, 7 minus 3, 4, 2 minus 4, minus 2. So this is the matrix. And also you can simplify. If you divide each and every term with 2, it is 2 by 2, 6 by 2, 4 by 2, minus 2 by 2. And hence capital X become 1, 3, 2, minus 1. Yes. This is capital X. Next question. Define trace of a matrix and find trace of a 3 cross 3 matrix with entries 1, 3, minus 5, 2, minus 1, 5, 2, 0, 1. This is the question. Trace means, trace indicates the value which is sum of all principal diagonal entries. Here the question is, definition is asked as well as one example based on it. Trace means you have to simply write sum of principal diagonal entries is known as trace of a matrix. First I am going to write trace definition. You can define trace as sum of all principal diagonal elements. It is known as trace of a matrix. Right. Now here matrix A is given by 1, 3, minus 5, 2, minus 1, 5, 2, 0, 1. Now find sum of all principal diagonal entries. Adding all three, we get trace, and from this you can write trace of A is equal to 1 plus minus 1 plus 1. Plus 1 minus 1 gets cancelled. Finally we get answer 1. Therefore trace of A that is equal to 1. Let us move to the next one. capital A is a matrix of order 2 cross 2 with entries I 0 0 I. Then find A square. A square is A multiplied itself one time, right? Since A is given as I 0 0 I, you can write this as, by taking I common, we get 1 0 0 1. Also you can write I multiplied by identity matrix. Next, here the aim is to find A square. A square written as A into A. A written as small I into identity matrix. It is multiplied by I into identity matrix. I imaginary, the meaning here iota. I into I, that is I square. Next, identity matrix whole square. I square value minus 1. Why? Because iota is defined by I equal to root over minus 1. Square root of negative unity is defined by iota. This is from complex numbers, and hence I square value minus 1. Yes, using this I square written as minus 1, and also identity matrix multiplied by identity matrix gives the result again identity matrix minus 1 into 1 0 0 1, that gives the result simply minus I, or you can write minus 1 0 0 minus 1. This is your answer. Or otherwise directly without doing all this, you can also simplify in this way. Method 2, A into A, that is A square, it is equal to I 0 0 I. Next, I 0 0 I. Product of two matrices. Here you have to write I into I square, 0 into 0 0, I into 0 0, 0 into I 0. Next, 0 into I 0, I into 0 0, 0 into 0 0, I into I square. So that what we get? I square 0 0 I square. So finally we get minus 1 0 0 minus 1. So this is your answer. This is another method, or simply you can write by taking iota common we get identity matrix. So I into identity matrix, I into identity matrix, I into I square value minus 1, identity into identity gives again identity whole square is identity, so that the same result we get. Let us move to the next one. A and A square are here, then find the value of K. A very important question. First given data I am going to write. Capital A is given as 2 4 minus 1 K. This is about A. And also given A square, it is 0 0 0 0. Then we need to find the value of K. Since A square, it is equal to 0 0 0 0, I can write A square value A into A, that is 2 4 minus 1 K multiplied by 2 4 minus 1 K. This is equal to 0 0 0 0. Yes, I am going to simplify this. Product of two matrices gives again a matrix, and equate this with null matrix. Product of these two matrices, 2 into 2 4, 4 into minus 1 minus 4. Next, 2 into 4, that is 8. Next, plus 4 into K. After that, minus 1 into 2, minus 2. Next plus k into minus 1, that is minus k. Minus 1 into 4, minus 4. K into k, that is k square. Now, two matrices are equal, implies by the definition of equality of matrices, their corresponding entries also equal. Just 4 minus 4, here it is 0, 0 equal to 0, no need to equate that. Next here, 8 plus 4k equal to 0, also minus 2 minus k equal to 0, also k square minus 4 equal to 0. These are the three possibilities to get the value of k. From this I can write 4k equal to minus 8 and the value of k equal to minus 2 here. Next, from this k equal to minus 2, and here k minus 2 into k plus 2 is 0, so that the value of k either plus 2 or minus 2. The common value of k from all the three, you have to write the answer. Here you have only minus 2, there only minus 2, but here you have plus 2 minus 2, but the common value of k is your answer. Therefore, k equal to minus 2. Very, very important question, many times asked in the public examination. Next, A, B, there are two matrices, then find A plus B transpose, that is the question. Since A, whose entries minus 2, 1, 0, 3, 4, 5. Next, capital B is a matrix with entries 1, 2, 4, 3, minus 1 and 5. Next, A plus B transpose. You have to write A first, minus 2, 1, 0, 3, 4, 5. Next, plus B transpose, 1, 2, 4, 3, minus 1, 5. This is transpose of B. Transpose means interchanging rows and columns, we can obtain another matrix, that is transpose of given matrix. Now, adding up these two, we get minus 2 plus 1, minus 1, 1 plus 4, 5, 0 plus minus 1, minus 1, 3 plus 2, 5, 4 plus 3, 7, 5 plus 5, 10. So, this is required matrix. Next question, show that A into A transpose equal to A transpose into A when the matrix A is of order 2 cross 2 with entries cos alpha, sin alpha, minus sin alpha, cos alpha. See, since A is cos alpha, sin alpha, minus sin alpha, cos alpha, implies you can write its transpose equal to. You have to interchange rows and columns, cos alpha, sin alpha here, minus sin alpha, cos alpha here. First find A into A transpose and then find A transpose into A and then check whether they are equal or not. Yes, A into A transpose, I am going to find A, you have cos alpha here, sin alpha, next minus sin alpha, cos alpha. It is multiplied by its transpose, cos alpha minus sin alpha, and here it is cos alpha. Yes, product of these two. cos alpha into cos alpha plus sin alpha into sin alpha. First row, first column, we are going to use cos alpha into cos alpha, cos square alpha, sin alpha into sin alpha, that is sin square alpha. Next, cos into minus sin, that is minus sin alpha into cos alpha. Next, product of these two, plus sin alpha into cos alpha, and after that minus sin alpha into cos alpha, minus sin alpha cos alpha. Next, cos into sin with plus sign, cos alpha sin alpha. Next, minus sin alpha into minus sin alpha, that is sin square alpha, plus cos alpha into cos alpha, written as cos square alpha. Yes, now on simplification, sin square alpha plus cos square alpha value equal to 1. You know that. So that what happens, observe. Here you have trigonometric identity sin square alpha plus cos square alpha. That can be written as 1 here. And these two gets cancelled. These two gets cancelled. So that we get 0, 0. 1, 0, 0, 1. This is identity matrix, that is first result. Next, we need to find A transpose into A. So first you have to write transpose, cos alpha minus sin alpha, sin alpha cos alpha, and after that A is cos alpha sin alpha minus sin alpha cos alpha. On multiplication, cos into cos, cos square. Next, minus sin into minus sin, sin square. So that we get cos square alpha plus sin square alpha here. And after that, cos into sin minus sin into cos. That is sin alpha into cos alpha minus sin alpha into cos alpha. Next, sin into cos, cos into minus sin, that is sin alpha into cos alpha minus sin alpha into cos alpha. Sin into sin, sin square, cos into cos, cos square. So that trigonometric identity we get sin square alpha plus cos square alpha. Here these two gets cancelled, and by trigonometric identity it is 1. These two zeros and here 1. This is result 2. Both are identity matrix. Therefore, A into A transpose equal A transpose into A. This is the solution. Next, A, B, two matrices are there. A, B transpose, whole transpose, that is the question. A into B transpose, whole transpose. Here we have to apply the property AB whole transpose equal to B transpose into A transpose. Using that property we can find the result. Yes, first given data I am going to present in the solution. A is given as entries 2, 0, minus 1, minus 1, 1, 5. Next, capital B, minus 1, 1, 0, 0, 1, minus 2. Now the aim is to find A into B transpose whole transpose. That can be written as first B transpose transpose, next A transpose. You know that the property AB whole transpose written as B transpose into A transpose. Using this property, first you have to apply transpose to the second matrix B transpose and then for first one. And also A transpose whole transpose is clearly A. so that it is equal to B into A transpose. Matrix B you have here -1 1 0 0 1 -2 multiplied by transpose of A, transpose of this matrix 2 0 1 here, sorry 2 0 -1 -1 1 5 here. Okay, now multiply these two, we get required answer -1 into 2 -2, 1 into 0 0, 0 into -1 also 0. Next, first row second column combination, -1 into -1 +1, 1 into 1 1, 0 into 5 0. Next, second row first column, 0 into 2 0, 1 into 0 0, only -2 into -1, that is 2. So 0 0 plus 2 we get. Next, second row second column combination, first 0 into something 0, and then 1 into 1 1, 5 into -2, that is -10. So that what we get, -2 plus 2 plus 2, this is -2 plus 2, next here 2, and here 1 minus 10, that is -9. So this is your answer. So these type of questions frequently asked in the previous public examinations, they are very simple, just addition, subtraction, multiplication of matrices, and some of the definitions like define trace of a matrix, define triangular matrix, and define upper triangular, lower triangular matrices. Such type of definitions along with fundamental operations, addition, subtraction, multiplication, and transpose of a matrix, those type of concepts, questions we are going to get in the public examinations. This is very simple question, easily we get 2 marks. Thank you.